Imagine the universe as a grand orchestra, an ever-expanding cosmic symphony performed by an unimaginable number of celestial bodies, stars, planets, moons, and asteroids, all moving in perfect rhythm across the vast canvas of space and time. Each object plays its part in a galactic score that stretches across billions of light years, weaving an intricate melody that has echoed since the dawn of time. Among this spectacular ensemble lies one particular section that continues to mystify and enchant astronomers: the domain of exoplanets. These are not mere rocks drifting through space. They are entire worlds, some desolate, others bursting with dynamic activity, and a few potentially teeming with the building blocks of life. Exoplanets exist beyond the reaches of our solar system, hidden deep within the Milky Way and other galaxies. For centuries, they were relegated to the realm of speculation until, in recent decades, science turned those speculations into discoveries. Today, we know of thousands of these distant worlds, but among them is one especially captivating planet, Proxima b, an exoplanet that seems eerily familiar and yet profoundly enigmatic. It may very well be Earth's cosmic twin, located just 4.2 light-years away in the Alpha Centauri system. Proxima b orbits its parent star, Proxima Centauri, which is the closest star to our own Sun. In astronomical terms, this makes it part of our galactic neighborhood, close enough that a future spacecraft could conceivably reach it within a human lifetime. Its relative proximity, coupled with promising traits, has elevated Proxima b to the forefront of planetary science, making it a focal point in the search for habitable worlds beyond Earth. But to appreciate Proxima b and its significance, we first need to understand the sheer scale of the cosmos. The Milky Way alone is home to an estimated quadrillion exoplanets. That's a 1 followed by 15 zeros. To help visualize this, imagine if each of these exoplanets were the size of a grain of sand. We wouldn't just fill the Grand Canyon. We'd have enough grains to build a second canyon 4 miles wide and equally deep, Grand Canyon 2.0. And this is just one galaxy among potentially trillions. Even more compelling is the fact that about 20% of these exoplanets are classified as Earth-like. This means they have similar size, composition, and likely harbor atmospheres. Some may even possess active geology and magnetic fields, both vital for sustaining life. Statistically, this suggests that 1 out of every 5 stars may host a planet not unlike our own. Multiply that by the staggering number of stars in the universe, and the odds of finding another Earth, or perhaps several, begin to seem less like fantasy and more like eventual discovery. Supporting this cosmic treasure hunt is a technological marvel that has transformed the way we look at the universe: the James Webb Space Telescope. Launched to succeed the Hubble telescope, JWST is not just an evolution, it is a revolution. With a 6.5-meter primary mirror that dwarfs Hubble's, by comparison, JWST can detect the faintest whispers of light emitted billions of years ago. It can peer through clouds of interstellar dust, explore the atmospheres of exoplanets, and even investigate the earliest galaxies formed after the Big Bang. But what makes JWST truly revolutionary is not just its size, it's the suite of sophisticated instruments on board, including infrared cameras, high-resolution spectrographs, and analytical tools that enable a kind of remote planetary autopsy. These tools don't merely capture images, they decode light itself, splitting it into its spectral components to determine what gases make up a planet's atmosphere, how dense it is, how hot or cold it may be, and whether it contains critical compounds like water vapor, methane, carbon dioxide, or even oxygen. In short, JWST is part telescope, part laboratory, and part detective, unraveling clues about distant worlds without ever leaving orbit. Now let us return to Proxima b. This small rocky world is roughly 1.17 times the mass of Earth and orbits its host star in just 11 Earth days. Because its star is a red dwarf, smaller and cooler than our Sun, Proxima b's close orbit places it within the star's habitable zone. This so-called Goldilocks zone is not too hot, not too cold, but just right for the possibility of liquid. Water on the surface, one of the key ingredients for life as we know it. Imagine vast oceans, meandering rivers, and storm-lashed coastlines. Picture a world with breathtaking landscapes, alien skies tinged in red from its dim star, and the potential for exotic ecosystems unlike anything we've ever encountered. However, this world is no paradise. at least not by earthly standards. A single day on Proxima b lasts about 11 Earth days, potentially due to tidal locking. This means one side of the planet may always face its star, bathed in perpetual daylight, while the other side is locked in darkness. The result could be extreme temperature gradients, fierce atmospheric currents, and a delicate balance between frozen night and scorching day. The twilight zone, a ring of perpetual dusk between these two hemispheres, might be the most stable place for life to flourish. So how do we study such a remote and strange world with any confidence? The answer lies again with JWST and its capabilities. It acts like a forensic lab in space, performing remote sensing that rivals Earth-based medical diagnostics. By analyzing the unique fingerprints of light absorbed or emitted by molecules, in Proxima b's atmosphere, scientists can determine whether it contains clouds, oceans, organic compounds, or even biosignatures, clues that hint at life itself. But science is never without surprises. In a moment that felt straight out of a sci-fi film, researchers once detected a peculiar signal originating from the direction of Proxima b. It was a narrow-band, highly structured electromagnetic pulse, one not easily explained by natural phenomena. For a time it was speculated to be a techno-signature, a possible artificial transmission created by an intelligent civilization. The excitement was palpable. Was this the moment we had been waiting for? A sign that we are not alone? And just as suddenly as it arrived, the signal vanished. It never repeated. No follow-up transmission was detected. It left behind a flurry of hypotheses. Was it a cosmic anomaly? An unrecognized natural occurrence? A reflection of our own equipment? Or could it have been a fleeting glimpse of something or someone reaching out? This hasn't deterred scientists. In fact, it has inspired them to search harder. A research group from Harvard is now working on enhancing JWST's capabilities to detect artificial light signatures, essentially scanning exoplanets for signs of city lights, power grids, or other indicators of civilization. They aim to observe both the night and day sides of exoplanets, looking for dim glows that might suggest not only life, but intelligent, technologically advanced life. Imagine the thrill of spotting the faint glimmer of alien streetlights, softly illuminating a world more than 4 light-years away. In the cosmic narrative that we are only beginning to write, Proxima b is a compelling chapter. It embodies both our scientific hopes and philosophical questions. What defines habitability? Could life evolve under alien skies? Are we truly alone or merely one voice in a vast galactic chorus? The James Webb Space Telescope is not just observing the stars. It is changing our understanding of the universe, of ourselves, and of our place within this vast, mysterious existence. The ink on this story is far from dry. Each discovery adds another paragraph, and with every observation we inch closer to perhaps the greatest revelation of all, the confirmation that somewhere, among the stars, another world might be watching back.